Now it starts. Okay. All right. So here we go. A man, a mass of 80 kilograms, pulls a pot of gold with a force of 120 newtons. The pot of gold weighs 500 newtons and moves at a constant speed. Okay. Again, look, I'm seeing the words constant speed, and now I know that the forces are balanced. Okay. All right. So let's draw the interaction diagram. So we have the pot of gold, the man, the ground, and the earth. Okay. I would probably, whenever it's a pull, right, you see how there's a rope here? If you count the rope separately, then it's going to be kind of a mess, right? Because you're going to need to include a diagram of the rope. I would just consider the whole pot of gold and the rope as being one thing. Okay, that way the man directly touches the pot. Okay. All right, so that's going to be, not a normal force. That's a pull, so that's going to be a tension. Okay, because the man is pulling on the pot, and the pot is pulling on the man. All right, the man is pushing against the ground, so that's a normal. And since he's moving, right, he's walking, there has to be some friction on his feet, okay, so that he can walk. All right, the pot of gold is also pushing against the ground, all right, and is also moving, so it's also going to have a force of friction, all right? All right, so it's easier just to think about this kind of sliding along the ground. Just keep it simple, all right? And then everybody gets a gravity. Gravity, okay? All right, so let's start with the pot of gold. So I can see that the pot is getting 4 interactions. Okay, so I'm P for pot. And I'm going to start with the force of gravity. All right. Fg, pot, earth. All right. And upward from the ground, force normal, pot, ground. All right. And those two have to be equal, and they need to be balanced, one way, one the other way, so that there's not even any motion up and down. Okay. Let alone any change. There's no motion at all. Okay. All right. Now, the pot feels the man pulling him which way? Okay. So the pot is feeling it in this direction. So FT, pot, man. Okay. Because the pot feels the tug to the right. Okay. So if it's at a constant speed, that means that the friction must be to the left. FF, pot, ground. Okay. All right. So let's see what's happening with the numbers here. All right. The man pulls with a force of 120 newtons, okay? So that's this one. So that is 120 newtons. So the force of friction also has to be 120 newtons because it has to be balanced, okay? All right, now let's look for the weight of the pot or the mass of the pot. Let's see what we've got. Let me use a different color. Okay, so look, the pot of gold weighs 500 newtons. That's already a force. Okay, so do you see how this is already in newtons? That means you don't have to do anything to it. It's already the weight. It's already the Fg. Okay, you don't have to multiply by 10 because if you did, you'd have Newton over kilograms. Like nothing cancels. Okay, so that's already giving you the weight because it's in newtons, which means this one also has to be 500. Okay, all right, next let's look at the man. Okay, the man is getting 4 interactions. Okay, so the man also gets a gravity, Fg, man, earth, and upward, Fn, man, ground. All right, so that takes care of those two. All right, now, the man and the pot are interacting, okay, and the man is pulling to the right, which means he is being pulled to the left, right? Remember, the force diagram is what he's feeling, not what he's doing. Okay, so man, pot is actually going to be to the left. Okay, because even though his action is to pull to the right, which means he is being pulled to the left. And if he's moving at a constant speed, the friction on his feet must be pointing to the right, or else he can't move. Okay, all right, so let's take a look at the numbers we have. We see that the man's mass is 80 kilograms. Okay, so again, if we want to use our new equation, 80 kilograms times that slope from the lab, 10 newtons per kilogram, gives me 800 newtons because those cancel. Okay, So he's 800 newtons, which is why I drew it bigger than the other force of gravity. Okay, so that means this has to be 800 newtons. All right, and then now I'm looking for my pair. Okay, so I have pot and man. So I'm looking for the pair that includes pot and man, and there it is. Okay, so this and this are the Newton's third law pair. Okay, so if that's 120, that means this one's 120, which means this one's 120. Okay, and I want you to circle the pair. That's very, very important to me that you can find the pair. Okay, all right, good, one more.